Hello students, and welcome to section 2-2, point slope form. Today we're going to be taking a look at another version of using a linear function in a variety of ways. It's going to allow us to do graphing, but also some other analysis where we're using the algebraic expression to help guide us. Example 1. Understand point slope form of a linear equation. How can you write the equation of a line using any points on a line? Let's take a look. Use the slope formula to find the slope using a specific point, x1 comma y1, and as you can see, x comma y. So here's how it's going to frame up. So if you take a look, we have our slope formula, as we've already discussed. Slope m is equal to y2 minus y1 over x2 minus x1. We substitute x for x sub 2 and y for y sub 2, or x2, y2 we also say again. In doing so, we have a version of the slope formula that is very similar, but of course x and y are replacing, like we see here, x sub 2 and y sub 2. Turns out that we can multiply both sides by x minus x sub 1, as they describe here, and they show in green obviously, so that you're left with y minus y sub 1 equals m times x minus x sub 1. So again, we're using the slope formula, plugging in an arbitrary point, x comma y, replacing it. Now in the next step, multiplying. Here you see your version, and then the final version actually just flipped is what the point slope form of the equation of a line is. That is the equation of a line, but in point slope form. You can write the equation of a line using any point x1, y1, and the slope in this form, point slope. Form y minus y1 equals m times x minus x1 in parentheses. Part B. Why is it helpful to have point slope form in addition to slope intercept form? The primary reason for this, using point slope form allows you to write the equation of a line without knowing the y-intercept. You can use any 2 points on the line to write the equation. It's a very powerful thing that you can do, knowing again, not y equals mx plus b per se, but in this case, a point, so x1, y1, and the slope, m. Any 2 points will allow for this. Next, example 2. A line with a slope of a half passes through the point 3 comma negative 2. What form can you use to write the equation of the line? What is the equation in that form? So let's start off. The slope and a point on the line are of course known. So we're going to use point slope form. So again, here's point slope form, this new version. We continue. We're going to substitute 3 for x sub 1, negative 2 for y sub 1, and a half for m. So again, y sub 1, there it is, negative 2. 1 half, there's m, and then lastly 3, there's x sub 1. Continuing by simplifying, y plus 2 equals 1 half times the quantity x minus 3. The equation in point slope form, therefore, is this. Y plus 2 equals 1 half times the quantity x minus 3. Part B. What is the equation of the line that passes through negative 4 comma 1 and 2 comma 3? Find the slope of the line first using the 2 given points. Remember the slope formula. y2 minus y1 equals x2 minus x1 divided by, y2 minus y1 over x2 minus x1. And of course, in this case, when you do the math with 2 comma 3 is x2, y2, negative 4, 1 is x1, y1, 3 minus 1 divided by 2 minus a negative 4. And the denominator particularly becomes a plus a positive 4, so we have 2 over 6, and you can see they've simplified as 1 over 3. Use the slope and 1 point to write the equation. Y minus y1 equals m times x minus x1, so if we substitute 2 for x sub 1 and 3 for y sub 1, and of course a third for m. This is the version that, again, is point-slope form. So the equation in point-slope form is this: y minus 3 equals 1/3 times the quantity x minus 2. Sketch the graph of a linear equation in point-slope form. What is the graph of y minus 3 equals negative 2/3 times the quantity x plus 1? To do this, we're going to, in step 1, identify a point on the line from the equation and plot it. Again, looking at this equation, it may or may not be obvious that when we look at it, rewriting it where you have x sub 1, y sub 1 in context would technically be what? Negative 1 as x sub 1 and 3 as x sub 2. So when you plot negative 1 comma 3, and as it turns out, they've already denoted with these green arrows down and right, as you see negative 2 and 3. Down to right 3 is of course going to land at 2 comma 1. If you see that and make a note of it, you'll understand how it nicely ties into what we've been doing. Step 2, as they describe, and as I already noted with the green arrows, use the slope to plot your second point. Negative 2 over 3 is again the vertical change over the horizontal change, or rise over run, if you recall. And again, move 2 units down and 3 units right from the first point. Plot the ordered pair 2 comma 1 as I already described. And then step 3, of course, sketch the line through those 2 points. And there you have it. The key to this particular problem that makes it, I think, more worthwhile as opposed to maybe some of the other problems we've seen with the slope-intercept form. Point-slope form is great here because you can identify very nicely here these 2 points, or these 2 values, pardon, this single point. To get the other points so that you have 2 points, you of course use the slope from, again, this point at this stage of the process. So again, there's your line, and again, point-slope form is very nice in that regard. Example 4. Apply linear equations. An event facility has a banquet hall that can hold up to 250 people. The price for a party includes the cost of the room rental plus the cost of a meal for each guest. Marissa is planning an event for 75 people. She has budgeted $1,200 for the party, and will it be enough? To kick the problem off, we can see here a depiction of a graph, of course, but number of guests measured against total cost. So as you can see, 50 guests is at $725. 100 guests is at $1,325, 150 here, and so on. So you can see the progression, right? As again, it turns out we can formulate our plan by determining which form of a linear equation is most useful or more useful. There's only 2 to choose from. The number of guests and the total cost represents different data points on a line. The point-slope form, therefore, is more useful. We're going to compute. Well, because we're going to be using point-slope form, here's how we compute. The slope represents the cost of each meal, so dollars per meal, if you think about it that way. Use the 2 points, 50 comma 725 right here, and 100 comma 1,325 to find the slope, which we'll do right now. If you do that, again, m equals y2 minus y1 over x2 minus x1. We subtract in the numerator the 2 y's. As you can see, again, here is your y sub 2 and your y sub 1 subtracted. You're substituting and subtracting. Then, of course, these 2 subtracted. And there you have it. That math lends itself, as you can see, to this particular slope. So the slope of the line between those 2 points is 12. As we continue, there it is. The slope 12, again, is the cost per meal. Use point-slope form to find the cost of the event for 75 guests. Therefore, here's your equation. Y minus y1 equals m times x minus x1 in parentheses. We can plug in 12, as we know, again, for our slope. We have a value of, for x sub 1, that is, of 50. and another number there, as you see, 725. So for 75 people, how is this going to play out? The cost for that number, if you do the math, go ahead and plug in 75. Just to highlight again why 50 and 725 were plugged in. That was a point on the graph from up above. This is the very first point we kind of looked at there. So I'm plugging in 50 and 725 for the very first point, but I'm also now solving for what y happens to be when you plug in 75. I think that's pretty nice to see here. We can do that very nicely, as you can see if you do the math. Not only are you doing the math here, right? You take 25 times 12 and then add 725. So you have 300 plus 725, where of course you do that, 1025. So when x equals 75, the cost for those number of guests is 1025. Since Marissa budgeted $1,200 for her event, she will have enough money. Please continue in looking at some of these triad examples and do the homework for tonight.